So number 63, it says determine the relative extrema for the function from 0 to 2 pi, and then you can confirm your result. So we're given the equation as y equals e to the x cosine of x. How do I find the relative extrema? What's my first step? Take the derivative. So I'm going to leave e to the x alone. What's the derivative of cosine? Negative sine. And now I take the derivative of e to the x, which is still e to the x, and I leave cosine alone. What can I take out of both of these terms? E to the x, so I'm going to do that. And what am I left with? Cosine minus sine. And what do I do with the first derivative to find my extrema? Equal to 0. So either e to the x equals 0 or this equals 0. If I have e to the x equals 0, how do I go about solving that? Natural log both sides. What's natural log of 0? You can't do it, okay? E to the x will never equal 0. That's an exponential function, okay? It never hits the x-axis. It never equals 0. So then I'm going to set the other one to 0. If this equals 0, I'm going to add the sine over, so I would have cosine of x equals the sine of x. Go ahead and get your unit circle out. Now. All right, where are cosine and sine, where are the x and y equal to each other? Pi over 4, they're both positive, square root of 2 over 2, and where are they both negative? 5 pi over 4. So those are my two x values here. Oops, equals, there we go, pi over 4 and 5 pi over 4. So any questions on that? Okay, then how do I find whether they're maxes or mins? Second derivative, so let's find the second derivative. And you can either use this here or you can use this here. It doesn't really matter. So let's just use this piece. So if I take the derivative, I'll leave e to the x alone. And I'm going to take the derivative of this piece. What's derivative of cosine? Negative sine. And derivative of this minus sine is? Minus cosine. Plus, I'm going to take the derivative of e to the x. And I'm going to leave this piece alone. And then I'm going to multiply this through to see if anything cancels. Does anything cancel? These cancel, don't they, the cosine pieces? And can I combine the sine pieces together to give me negative 2 e to the x sine of x? So this is my second derivative. What do I do with my second derivative? I put these critical points into it, right? So let's find f double prime of pi over 4. So if I plug in pi over 4, this is negative. E to the pi over 4, positive or negative? You might have to try it in your calculator. So is e to the pi over 4 positive or negative? Just check it. Positive. Yep, it should be positive. So we have a negative times a positive. And then I have sine of pi over 4, which is what? Positive again, right? So if I have a negative times a positive times a positive, is this greater than 0 or less than 0? Less than 0. So is this a max or a min? Max. So there's a max when x is pi over 4. So I'm going to write that kind of down here. Relative max is going to be at pi over 4 comma something. And we'll find that something in a little bit. Okay, and then if I try the second derivative at the other, 5 pi over 4. I still have negative 2e to the 5 pi over 4, so try that in your calculator. And then sine of 5 pi over 4. Is e to the 5 pi over 4 positive or negative? Positive. So I have a negative times a positive, and is this positive or negative? Negative. So it ends up being greater than 0, so there's a min there, right? So relative min is at 5 pi over 4 comma something. How do I find the something? Plug it in the original. And our original for this was, whoops, pi over 4, not pi over pi. E to the x, which will be e to the pi over 4, cosine of x, which will be cosine of pi over 4. And cosine of pi over 4 is, so this is like square root of 2 over 2 e to the pi over 4. I'm going to leave it like that if you want a decimal so that you can check your answer, because they say you can use your calculator to check your answer in the end. That's fine. What'd you say, Clayton? Yeah, they probably have it as a decimal. It should match if you put it like that. And if you put it as a decimal, you're going to be able to compare your answer easier. This is the exact answer. Okay, then we'll find it at 5 pi over 4. So we would have e to the 5 pi over 4. And then cosine of 5 pi over 4 is what? Negative square root of 2 over 2. And then I still have that e to the 5 pi over 4. So this would be our exact answer there. And I'm assuming those are right. I don't see anything we did wrong there. But if you want to compare it with the back, if yours is a decimal, just punch that in. So any questions on the process of those? All right, number 65, it's easy to get messed up on this one because of what they're asking for. So it says here, plants do not grow at constant rates during a normal 24-hour period because their growth is affected by sunlight. Suppose that the growth of a certain plant species is a controlled environment, and it's given by this model, so I wrote that down, where h is the height of the plant in inches and t is the time in days, with t equals 0 corresponding to midnight of day 1. See the figure. Okay, let's see here. During what time of day is the rate of growth of this plant a maximum and a minimum? So it's asking, and this is where people miss it, during what time of day is the rate of growth a max and a min? So we're trying to find the max and min of the rate. How do I find the rate? Derivative. So first I have to find the derivative to even find what I'm looking for. So what's the derivative of 0.2t? 0.2. And back here, I'm going to pull that constant out front. What's the derivative of sine of 2 pi t? Derivative of sine is cosine. So I have cosine of 2 pi t. And then what do I have to remember to multiply by? 2 pi. So this is the function I'm trying to find the max or the min of. Okay, so I should probably have a prime there. So this is 0.2 plus, if I multiply this by 2, I get 0.06 pi cosine of 2 pi t. Okay, so pretend like this is my starting function, because this is what I'm trying to find the max or min of. So to find a max or min, we take the derivative, find our critical numbers, take the second derivative, plug them in. So pretend this is the original. Okay, this is my rate, so I'll write rate equals. So let's take the derivative of that. Derivative of 0.2 is 0. Derivative of this, I'm just going to pull the constant out front. Derivative of cosine is? negative sine. So I'd have negative sine of 2 pi t, and I need to remember to multiply by 2 pi. So right now I have 0.06 times 2, which gives me 0.12 pi squared. And I'm going to pull that negative out front, so let me do that now. And then I still have sine of 2 pi t back here. What am I going to do with this? Set it equal to 0. Is it looking like this is going to be easy to find on my unit circle? Probably not, right? So we're going to have to use our calculator here, but let's set it equal to 0. Couldn't I divide this stuff over? So really I'm just trying to find when sine of 2 pi t. Actually, we could find this on the unit circle. It looks ugly, but it's not too bad. So I'm going to go ahead and grab this unit circle and pull it down here. So when is sine equal to 0? So sine is the y-coordinate, so it equals 0 here at 0 and 2 pi, and also over here at pi, right? So I know this piece here, sine of 0 equals 0. So this 2 pi t is going to equal 0. It's going to equal pi. It's going to equal 2 pi. Isn't it going to equal 3 pi, 4 pi, and so on, right? Because this one doesn't necessarily give me a limit as to what I'm doing. And then how do I solve for t? Divide everything by 2 pi. So if I divide everything by 2 pi, I still get 0. What's this going to be? 1/2. The next is going to be 1, then 3/2 and 2, and dot, 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 right? So these are my what? What's the name for these numbers? These are your critical numbers, right? So how do I find whether they're maxes or mins? Plug them in the second derivative and see whether it's positive or negative. So we need a second derivative here. And I'm going to take the second derivative of this piece here because that's cleaned up. So that constant you can leave out front. Derivative of sine is cosine. So it's going to be cosine of 2 pi t times 2 pi again. So if I take that 0.12 times 2, I get negative 2.4 pi to the third power cosine of 2 pi t. And I'm going to plug in 0, and then I'm going to plug in 1/2 and 1 and 3/2, and we'll probably see a pattern if we start doing these. So how about we put this into our y equals, and we just find it at those values, and we'll just say whether it's positive or negative. So I would put this in my y equals, go to your table, start at 0, go by 0.5s. We're just going to say if it's greater than or less than 0. Everyone should be putting this in their calculator. I think if we get to here, we'll probably see what's going on. So I just put the second derivative in my y equals. I'm going to my table set. I'm going to start at 0 and go by 0.5 because that'll give me each of these values. And then we can go ahead and look at the table here. It's a little too hard to read there for me. So the first one here, at 0, it's greater than or less than 0? Less than. Here it's greater than. Here it's less than. And doesn't it keep just going back and forth? Okay, so this top row, if it's less than, these are what? If it's less than, it's concave down, so it would be a max, right? So these are maxes up here, and these are mins down here. Questions on that part? And what is our goal, I guess? Let's make sure we answer the question, because I don't know that we need to plug it back in. During what time of day is the rate of growth of this plant a maximum? So do you see how it's a maximum at 0? So that would be how many days? 0 days. This would be at 1 day. This would be at 2 days. So what time of the day? T equals 0 corresponds to what? Midnight. So it looks like at midnight is when it's at its maximum. Okay, if I'm at a half, where are these mins occurring? At noon, right? Half of the day would be noon. So this is what it was asking for there. Does that correspond to what they say in the back? It's a controlled environment. It's not like out in the actual, you know, like a garden or something. It says it's in a controlled environment, so then it makes a little more sense.